So in this video we'll be introducing what is meant by mathematical sequence, and the various types of sequence you can get, and introducing the man, the myth, the legend that is Fibonacci. So a numerical sequence is a list of numbers that follow a particular pattern or a rule. So there are some common sequences that you may already know and or need to be aware of. So now the first one is just simply 1, 2, 3, 4, 5, 6, 7, etc. Now at A level and more advanced levels we class these numbers as natural numbers. You may just think them as just normal positive numbers. The next sequence is looking at even numbers. Odd numbers should be aware of, so 1, 3, 5, 7, 9, 11, etc. The next one is square numbers. So this is where we start moving into numbers that follow a particular pattern. So here we're looking at 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, 5 squared, which is 25, etc. And obviously where this comes from is actually using dots to draw squares. As you can see, depending on how this is coming out on your screen. And the number that we're dealing with is basically the length of the square, and so forth. The next one is looking at cube numbers, so that would be 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, etc. Which again is just 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, etc. So it's just a case of just multiplying the number by itself one more time, then from squared numbers. And then finally with triangle numbers. Now triangle numbers are 1, 3, 6, 10, 15, 21, and they're numbers that generate a right angle triangle. So if we start off with 1, then our next triangle is going to be like so. And those of you who have played pool or snooker, basically it's the number of balls you need to, let's say, make a triangle before you cue off. And so it can kind of be represented in sort of illustrative forms, or you can see is 1 as being just 1. The next one, 3, is just 1 plus 2. 6 is 1 plus 2 plus 3. 10 is from 1 plus 2 plus 3 plus 4. 15 I should say, missed that one out, is 1 plus 2 plus 3 plus 4 plus 5. So all you're doing is adding the sum of all the previous numbers together, and you get your triangle numbers as well. So there's different ways you can kind of remember. So if you can't remember these numbers like you would the spellings, as long as you understand where these types of numbers come from, you will be able to calculate them even with a use of a piece of paper and a pencil. So moving on to the next type, which is looking at Fibonacci. Now before we move on to Fibonacci sequence, I know that looks like a lot of reading to do. I'll just try and summarise or give you a chance to pause the video to give this a read. Now Fibonacci is a really important mathematician, and if you think back to the Romans, who are quite famous, in the Greek sort of mythology where maths was used and can be prominent in some of the structures that are used there, Fibonacci was one that kind of moved away from the Roman numerals. So if you've done the Roman numerals before, either at primary school or investigated it in your own leisure, then Fibonacci, or Leonardo Bonacci, was basically a Italian mathematician who moved away from Roman numerals while going in his market. I'm sure you can read this or do your own research on him, and kind of moved in and introduced our place value system, which we still use today. So he's quite revolutionary in terms of what he does, and obviously he has discovered other stuff in mathematics as well, which is really interesting. And I do strongly recommend that you research Fibonacci for his work on the golden ratio, which is heavily linked with his sequences, what we will look at in due course, and other things as well, where you can spot his sequence and his findings in nature and everything around you. So it's definitely worth a read and definitely worth a investigation. And what I'll do is I'll add a few other YouTube video links to things where you can investigate him and research him a little bit further. So moving on from that, so Fibonacci sequence is basically where, and again, Fibonacci was one that created this particular sequence, discovered this sequence from looking at rabbits. Now I'm not going to go into the details of what we're talking about with regards to these rabbits and what these rabbits are doing. That'll be for another YouTube video, that may be when you're a little bit older. But either way, it's looking at the sort of increase of rates of rabbits and what he's found. So now this particular sequence is discovered by adding the previous two numbers. So starting off with two numbers. Now Fibonacci initially started off with the number 1 and 1. Obviously one being one rabbit and the other being another rabbit, and then calculating on the reproductive system or values of which that would come, or the increased values I should say. So if we look at where the Fibonacci numbers come from, now the rule of Fibonacci is you start off with two numbers, so our starting two numbers are 0 and 1, and what we need to do to find the next number in the sequence is we add the previous two numbers together. So if we start off with 0 and 1, 0 plus 1 is 1. And then to find the next number, I'm then going to add the previous two numbers. So 1 plus 1 will give me 2. Then I'm going to add the next previous numbers. So 1 plus 2, which gives me 3. Then I'm going to add the previous two numbers, so 2 and 3, to get 5, and so forth. So this sequence can go on and on and on forever, but originally, Fibonacci's original sequence starts off with 0 and 1, which was later introduced, as you can see from the reading, and then continues from there. Now the nice thing about Fibonacci sequence is we can actually relate this to starting with any two numbers, and also incorporate algebra as well, which is sometimes a common theme when you're dealing with maths papers or homework questions that extend your knowledge of the Fibonacci sequence. So in this particular question, we're asked, using the Fibonacci sequence, write down the next 4 terms of the following Fibonacci sequence. So what we're going to do is start off with these two numbers, and we're going to write down the next 4 numbers. Now terms, we're going to look at vocabulary in a second, which is basically just another word for number in the sequence. So basically what this is asking me to do is to find the next 4 numbers in the sequence. So if I just do my 4 dashes, so I'm not going over, I know exactly that I'm finding 4, is what we're going to do is add the previous two numbers to work out the next number. So for this one here, I'm going to add 2 plus 6, which is 8, and I'll just write what I've done in little brackets there. So for the next number, I'm then going to add the next previous two numbers to this number here. So that's going to be 6 plus 8, which is 14. So that's 6 plus 8. The next number for this one here, I'm going to add 8 plus 14, which is 22. And for the fourth number, I'm then going to add 14 plus 22, which gives me 36. Now again, for B, I'm going to find the next 4 numbers. So here, it's going to be 22. Then it's going to be 12 plus 22, which is 34. Then it's going to be 22 plus 34, which is 56. And then 34 plus 56, which is 90. Now moving on to algebra, again, it might seem like, well, how could you add these numbers and letters together? Well, we can't. So we're just going to use collecting like terms to make it easier. So if I just create a little bit of extra space. So here I've got my first term as being A, my second term as being 2B. So here I'm going to, my next term, my third term, or third number in the sequence, is going to be A plus 2B. Because A and B are different letters, I can't join them up to make one sort of entity. They're just going to be 2 separate terms, and I could just climb it from there. Now for the next term, for this one here, I'm going to add the previous 2 terms. So what I'm going to do is I'm going to add 2B, 2. So I'm going to add 2B plus A plus 2B. So using collecting like terms, if you're not sure about collecting like terms, I'm sure I'll do a video on that. So here we've got A plus 4B. Then for this term here, I'm going to do A plus 2B plus A plus 4B, which gives us 2A plus 6B. And then for this term here, I'm going to add the previous 2 terms together. So I've got A plus 4B plus 2A plus 6B, which gives me 3A plus 10B altogether. And there you can see that I've found the next 4 terms of each of those Fibonacci sequences. Now, if you're concerned about when do I know when to use Fibonacci sequence, or when do I just try and find a rule, it will have to tell you that it's a Fibonacci sequence. So you only use this method when the name of Fibonacci is mentioned. So moving on from that, now the next thing we move on to is important sequence vocabulary. Now it's really important that as well as being able to do the maths, you're able to recognise some of the more mathematical words that are used in particular questions. And one of the common questions we always get asked as maths teachers when we're dealing exams is students not being aware of what words mean. And there are going to be very common words that are used, particularly in maths textbooks and exam papers and homework sheets, that you really do need to get like a real life understanding of what they actually mean. Now the word term in a sequence is basically a number in a sequence. So if I just write down as an example a sequence, so let's go for 3, 5, 7, 9, 11. So here I've got a sequence. Now 5 is the second term. 3 is the first term, 5 is the second term, 7 is the third term, 9 is the fourth term, and 11 is the fifth term. So if you were asked to find the next 5 terms of a sequence, so here I would write down the next 5 numbers that follow on from 11. Now the number, let's say the letter N, is basically the position of the term in a sequence. So in this, we can see here, if I get a different colour pen, so 3 is our first number, 5 is my second number in the sequence, 7 is the third number, 9 is the fourth, and 11 is the fifth number in my sequence. So in this, when n equals 1, the term is 3. When n equals 2, the term is 5. When n equals 3, the term is 7. When n equals 4, the term is 9. And when n equals 5, the term is 11. So n is basically the position of looking for. So a question might ask you to find the 10th number in the sequence. So that's basically where n is going to be 10. And that kind of makes more sense when we're dealing with the nth term, which we'll follow on in another video. Now the rule is basically a written instruction to get from one term to the next. So for example, the rule in a sequence you can see on the screen. So here we can say here that the rule. Now one thing that you may think to yourself, well, what's the rule of these numbers? You might say, well, add 2, because that's the difference between each of the terms in that sequence. When actually, when you're asked to write down the rule, it's always important to write down what number you're starting with. So starting with 3, and what we're doing is we are add 2. So it's really, really important, and again, I can't stress that enough, that whenever you're describing a sequence, always say what number you are starting with. So that's the rule. Now the nth term, now this is kind of moving on from a level of describing a sequence using words and using a rule. Nth term is basically a formula that links the position of a term to its value. So what the nth term is talking about here, so if I get a different colour pen, it's linking this number here to the term. So it's linking n equals 2. So I'm thinking about, how do I get from 2 to 5? How do I get from 3 to 7? How do I get from 4 to 9? How do I get from 5 to 7? Now the rule that links the n to the term is what we call the nth term. And that's basically, in other words, it's a mathematical formula that links the position of a term to its value. And then moving on from that, now there are also common types of sequences. Now depending on what level you are working at or what age you are, will determine how often you'll see these things. Now at basic level, I would say probably a linear sequence is basically what you're looking at. So a linear sequence is where the difference between each term is the same, and it could be positive or negative. So an example of a linear sequence is, let's go for 6, 10, 14, 18. Pen's a bit slow on this one. There we go. So as you can see, the difference between each of these numbers, so the difference between 6 to 10 is plus 4. The difference from 10 to 14 is plus 4. The difference between 14 to 18 is plus 4. So because the term to term difference is the same, it's therefore a linear sequence. Now, a geometric sequence, now this is when the next term is made by multiplying the previous term by a number. Now again, this is something that you probably see more in advanced sort of sequences when you're moving on to GCSE sequences, but it's important you know the difference between the two. So for example, if I had 2, 4, 8, 16, 32, so as you can see, the difference between 2 and 4 is 2, then 4 to 8 is 4, then 8 to 16 is 8, then 16 to 32 is 16. So you can see here that the difference between each term is different, so it's definitely not a linear sequence. But to get from one term to the next, now hopefully what you've spotted in these is the fact that it's just the previous number doubled. So here, the geometric sequence here, now to find the geometric sequence, all you need to do is divide one term by its previous. So for example, the difference between, or geometric sequence here, is the fact that if I do 4 divided by 2, it's going to give me 2. So basically what this is telling me is that starting with 2, we are doubling the previous number to get the next value. Now, quadratic sequence, this is where it's slightly different, and again this is something that you probably find in more higher level Key Stage 3 and also for higher sequences in GCSE, looking at quadratic sequences, and this is when the difference between each of the terms increases or decreases at a constant rate. If we look at an example of a quadratic sequence, I'll show you what we mean by the difference between each term increases or decreases at a constant rate. So for a quadratic sequence, let's have a look at 7, 10, 15, 22 and 31. Now if we look at the difference between each of these numbers, so the difference between 3 and 10 is, 7 and 10 is 3, 10 and 15 is 5, 15 and 22 is 7, and 22 and 31 is 9. And then if we look at the difference of the difference, we can see that there is a constant increase of 2 of the difference of the difference. Now what I tend to call this is what we call the double difference. It's the difference of the difference. So when you have got a double difference value that is constant, whether it's positive or negative, it will be a quadratic sequence. And like I said, depending on what year you're in or what level of mathematics you are studying, you will probably encounter 1, if not 2, if not all 3 of these types of sequences that you need to be able to be comfortable and confident in working with.